a Vic con un fuerte aplauso.
Hola, Boludos. And I think this is the only few sentences that I have learned in Spanish. So today I will present as in English, and since it's gone, okay. Now, today I'm going to share about the Scarlet OT, which we make a tool for OT adversary emulation for fun. And before we start, I would like to introduce myself. And I'm Vic Huang, and I'm from Taiwan, a technical community named UCCU Hackers. And I have shared my research in some conference in East Asia and also the Mid East. And my partner is so young; he's not able to attend Ekoparty in person. So I will usually we'll share the whole session by two parts, but he cannot come, so I will share the whole part. So this is our outline. Today I'm going to share from like a basic knowledge of the adversary emulation and why we're going to do it, and then how we do it. And this is the first part. And the second part that we are going to extend the attack chain from the ICS malwares we have reviewed, and we will have some demos on attacking devices, which is super expensive. We are so scared that we will turn it into a brick, but luckily we don't. And the final is the suggestions for enterprise who want to try adversary emulation in OT systems, and some takeaways. Okay, let's start. So industrial control system is used for control and monitor the industrial process. And there were two important parts inside. One is DCS, which is more focused on fine control, and it has customized protocols, depends on different vendors. So another part is the SCADA is used for remote control, and I think most of you have heard about PLC. It's for SCADA, and most of the security researchers researching SCADA because it's much easier for them to get the spec, for example, RFC of the protocols, and also the different vendors they implement the public control protocols just slightly different. So basically, you can ignore the difference. So that's why most of the researchers doing their research on SCADA, including us. And then this is the IT and OT domain in the ICS network. And you can tell that, this is the Purdue model we usually to describe the IT and OT domain in the ICS network. From the top level is level 4 and level 5. It's like normal IT devices, for example, Windows Office computer, something like that. And there will be a DMZ zone. They suggest that we should separate the IT and the OT, below level 3, to two parts to prevent attack. And then the level 3 below is operational technology, is named OT. And there are some Windows devices in the OT, but mostly they are devices which is try to control and process the industrial factories. So they're using the special protocols as I mentioned, and also there are some protocols is used for transfer the signal to the digital data. And if you have noticed, we are talking about attacking OT. You may see that you have actually you have to go through the IT. You have to exploit and go bypass some like protection in IT, and then you can get into OT. So I think that is a very important point. But like seldom vendors will share about this. Okay. Then the second part is what is adversary emulation. I think if you are here and you have listened to the last session, they have a great introduction about adversary emulation. And this is the ATT CK matrix for ICS. And this version is a little bit old because they just renewed the one new version, but the concept is the same. They just mapping putting the attacks in ICS to this kind of matrix, and it's using the TTP architectures, which is the highest level tactic is the targets of the behavior and the procedure, like is the detail, like how can you achieve this kind of attack. So basically you can describe attack from, for example, APT group to, and map it on the ICS matrix. So it's a good way to use the matrix by you map the attack with the matrix, and then you can do some tests on your own environment. So you can find out if your environment is vulnerable to this kind of like known threats or something, and it's as known as a BAS, like a bridge and attack simulations. So I believe there's a lot of solutions named like BAS, but they are doing this kind of things. I am not sure. And different from the meta exploit, this kind of like toolkits is more focused on the whole process, the attack process, because it's like a complete attack process from some APT group. And then we can find that in our knowledge, there are very few, especially open source tool for adversary emulation in IT, and also like very few in OT. But just 3 months ago, I think the MITRE has released a version of Caldera OT version, which is open source, but it doesn't include a lot of protocols. But we just we produced these tools for like almost 1 year ago. But actually, if you are interested in some kind of OT adversary emulation tool, you can check the Caldera plugin, which is focused on OT. So at that time, like 1 year ago, we want to build some kind of OT adversary emulation tool. So what we have to do is we need the background knowledge of what is the malware doing in your ICS network. So we try to review, analyze, and try to reproduce this kind of attack. And at first, we review the 22 ICS malwares from 2010 to 2022. And also, there's some sample which is not which is unpublished. And basically, you can see the famous one, the Stuxnet. And then there's POC Blaster, which is POC published in the Black Hat and also industrial, and the famous Triton malware. And then the recently highly focused on Erkland is industrial too. And we self-define it as 4 generations for their main purpose. For example, in 2021 to 2022, they focus on data stealing, like sniffing the traffic in the network, and start from 2015, there are like module design. It started to support several different kind of protocol attack in the one malware. And there is another malware named Triton, which focuses on only one protocols, but it is so complete. It has so many functions inside, so you can complete the whole attack process for the Triton, the SIS and Tri-Systems protocols. And then from 2017, there are like WannaCry, a lot of ransomwares, and it's also counted as ICS malware because they try to encrypt the old version of Windows devices in ICS network. And then from 2020, there are more. It's more like a toolkit kind of malware that focus on attacking more kind of protocols and also more customized. So if we want to focus on OT, especially protocols, we just pick like several important malwares inside. We can see the trend of the malware development from single protocols to multiple protocols, and it becomes a modular design. So quick summaries of these malwares. They have two main targets. The first one is the information collection, the sniffing. And the next one is they try to break the factory's operation by like any kind of method they can do. And there's three kind of ICS malwares. The first is the worm-like malware, which is focused on sniffing. And the second one is ransomware. I think everybody knows what is ransomware. And the third one is like highly focused on attacking protocol, is like toolkits, something like toolkits. And then I would like to share something we found during reviewing these malwares. The first thing is only few malwares is actually impact the devices in OT environments. The rest of them focus on like encrypt Windows or attack like an old version of Windows. So it's not actually attacking the devices in OT. And then second one, I think like most of security researchers won't share in their session, is we found some hard-coded IP address in their malware. It means these hackers knows the network topology in the internal system, and they know which devices they are going to attack. So it's like super strange because it must be something like information leakage before they build the malware, and so they can hard code the target IP address inside. And another thing is tag name information. In some kind of protocols, they are object-oriented. It means you can name your object by yourself and put some data inside as a record. And mostly they are, for example, I can put the pressures of my machine in one object named like 1, 2, 3. But usually, if the hackers don't know what is the object stands for, he will never try to like load the data from that object. So, but in some malwares, they know what exactly the tag they have to read or to overwrite. So it's like super strange. And then, actually, POC has 3 modes. It's like ROM mode and run-only mode, program-only mode, and hybrid mode. So if the malware is able to like upload the malicious code to POC, it means there should be some like misconfigurations on the POC because they are not turning it on the running-only mode. And also, last one is about the PLC blaster. There's a POC in the Black Hat US about they try to abuse the connection, the network connection between two POC as a proxy. So in the real world, normally the HMI POC will be deployed on like one-to-one in the network. So probably it won't work, but it depends. Okay, so we just pick the 7 or 6 malwares from those 22 malwares, and which is focused on OT. And then we self-define it as 4 stages. And not every malware has these 4 stages, but some of them have achieved like 4 stages. And they have 2 main targets, like data and control. And 4 stages discover, discovery, collection, and manipulation, and check and evasion. So 2 main targets about the first one is the data. So actually, the data is given by lower levels devices and sensors, and there will be a way that to display on the screen for human beings to read. So you can try to, if you are an attacker, you can try to like manipulate the data on the screen, or just try to like deploy some bad code, malicious code to the POC. And for control purpose, actually there are a lot of CVEs for these old like POCs or old devices, so they can use that kind of skills to attack some devices. And also, there's one kind of attack is abusing the devices. For example, they are sending like normal function, but you just ask the order the devices to do something like probably can make your factory fall down or something. So it's like abusing the normal instruction. So in the first stage is discovery. Normally the malware, these malwares will do some scanning in the network. So if you deploy some like protective solution, maybe in this stage you can find out like someone is scanning your internal network. And for example, like Triton is trying to send this specific packets and try to find out if there's a live devices in the network. But Triton has a very interesting design, is that it tries to prevent the malware get into the honeypot. So how do the Triton make it? Is like if he scan the network and he find out that it's only one device is alive in the network, Triton will immediately terminal, and then he will think that he's in honeypot environment, and so he don't want to do something like malicious. And for like control, actually, if you look into the function call in the Modbus, for example, which is deployed in a map, you can use the specific function call to scan your network and find out what kind of devices is alive, or is kind of like using Modbus. And then for the second stage is collection. In here is basically collecting the information for the next step. And the third stage is manipulation. As we mentioned, is try to make human to do like wrong decisions, or try to download the malicious code to POC. And then for the control purpose, that you can send the normal instructions to those devices and do something malicious. And here's a special case I want to mention is that some malware try to erase or overwrite their malicious code. For example, again, Triton try to write the meanness code to overwrite the malicious code that it has downloaded to the POC. And also, after he overwrites the meanness code to that POC, he will try to detect that POC mode to find out that the code has been like active or not. So it's like very special actions. And there's a quick summary of like 4 stages. And after we get this kind of summary, we use this summary to build our own tool. So here's overview of POC marketing, and a lot of famous vendors like Siemens and Mitsubishi, and they support their own protocols, but at the same time they will support some common protocols. For example, the Siemens maybe support S7, but some of the devices may also support Modbus, something like that. So our target is building a tool, so finding with the popular protocols is important, so that's why I put it here. And the design core of our tool is we want to make it flexible. For example, I think most of you have downloaded some payload, no matter it's related to ICS or not. Some CVE payload in the GitHub, but you try to run and it just tell you some error, but you actually don't know what happens during a running. So you have to look into the source code and try to debug, and sometimes it works, sometimes it's not. So it's super strange, especially for ICS, because it's harder for you to do debug things because it's running the bytes or something. So we try to break the one big step, one whole payload to the several small steps, and then you can do switch the orders or something by yourself, and also you can customize the comments by yourself. And also, as we mentioned that if you want to attack OT environment, you have to attack IT first, and we are not IT professionals, so we picked the Caldera, which is provide the IT adversary emulation, and we built a plugin of OT to the Caldera, and for education purposes. So we have support 10 different protocols and 23 techniques, and we just try to reproduce the malware's actions and try to reconstruct the malware's actions, which means that we try to reproduce the one, for example, the malware is attacking A protocol, and we just try to reproduce the same action in the B protocols. And this is how Caldera run. It's you have to deploy the C2 in your environment first. And then the C2 will deploy an agent. It can be in the same server. And then the agent will start to do the attacking things and gather the information of the response. And then you can see the results in the Caldera. And this is the example of we just rebuilt the Triton attack from the discovery to the end. So in the next part, we will show that how we extend and reconstruct the attack chain from those malwares. malware named Industrial have using this protocols, IEC 61850. It's a protocol for like a power station. And it has 3 levels, like station levels, bay levels, and process level. And for station level, they have a HMI, a human interface, and also SCADA. And it's used MMS to connect with their lower level, which is IEDs. So, and there's a protocol named Goose as a like publisher and subscriber the events or alerts between IEDs. And if something happens, it will send the message to the lower level, like in the process level. That's, for example, if your like electric power has some problem, maybe you have to trip. You have to do power trip, and after the publisher has shared the information to the subscriber, and then they will do like power trip. So how it works is like this. In the Goose protocols, there's SQNUM and STNUM. So STNUM is present as an event number. So here's the event number 1, and it will start to broadcast for several times. And each time it broadcasts, the SQNUM will increase. So, and the time, you can see there's a T0 or T1. At the first of the new event, the time zone between the two broadcasts will be shorter than after. So it's like there's a first of events, and the second event new event happens, the SQNUM will become 0, and then the STNUM, which is event number, will become 2, just increase 1. And there is a Goose PDU, which you can intercept in your like Wireshark, but normally Wireshark don't support the Goose structure, so we wrote the filters with Lua by ourselves to recognize the Goose packets. That you can see the STNUM and SQNUM is here, which we just mentioned about. It's an index of the events and alerts. And then the next important thing is there's a block of all data, which is the content of the event. And for black box testing, normally you won't know what is sent forth in the data block. It means you cannot understand what is going to happen if you try to flip the value in this data. So, but for abusing, the easiest way is you just sniff and you recognize you store the old data first at the first time, and you try to flip all the value to, for example, 0 to 1 and 1 to 0, and it should be a super abnormal condition in the factories, so that you can trigger the power trip. So there's another kind of attack vectors is that you can manipulate STNUM or SQNUM. It means you can just send out a fake packet and to make the subscriber to become confused. For example, your STNUM is 1 for now, and you just suddenly send out STNUM 2, and without any alerts, and then the subscriber will think it's disordered, and the machine will, normally the machine will just died. And we tried like several times, and luckily it's recovered. So the flow of attacking this like goose protocol is, first we use T# to capture the traffic, and then we destruct the frame, and then we added the ST_num or XQ_num, or you flip the old data, and then you send the mail form frame, and then you can achieve the attack. So we have a demo like this. So this is our test bed. And in here, the upper level is like a session level, and the second level is a publisher. It's a publisher. So the second level will publish the event to the third level. So if the third level, there's some like error or alerts in the third level, there will be a red light in the third level, and the blob will be deleted. So we test our attack process, and we find out the goose packets in the traffic, and we try to do, for now it's like no alerts for now, and then we try to send the fake alert frame to the network, and it triggers the subscriber to assume that there's a new event, an abnormal event. And then we send out a new attack again about like to make it has a power trip. So if it's a real power station and you have a ability to make a fake frame, you can make it the whole power station become the power trip. Okay, so let me go through. Yeah, so we send out the packet and it become red, and well, how can I see the process? Okay, so sorry for that. I will play again, and I'm not sure how can I skip the duplicate parts. So it's not yet alert, but we just try to send the fake packets. And then, yes, the blob lights, it means the mitigation, the protections action has been triggered. And I think these devices cost like 1,000 USD, but we are not so rich, so we borrow the devices from our amigo. And we are like super nervous to break it, because actually I test a lot of payload, and I bought a lot of devices by myself, and some of them I just send some denial of service instruction, and it becomes a brick, and I cannot make it recover. Okay, so then our next example is MailSec, and we are using the IQ-R modules of MailSec. And MailSec is the Mitsubishi Electric PLC's protocols. And it has some different like spec for the different modules. And the simplest is the MailSec F. And the most complicated module is the IQ-R. So we borrow the IQ-R for testing. And for example, there's a spec. You can read the Mitsubishi electric spec about the IQ-R modules. That they have different, a lot of like instruction inside. And this is a format. Here's a subtitle, which is a fingerprint for single devices. And the yellow part is like if you want to send a comment, you can put the comment in the yellow part, like which comment are you going to send, and the device number, and the device code. So it should be like this, for example. And the comment is like read some values from the registers in IQ-R, and then the devices 1 and devices 2 and devices 3 and distance, and where you're going to write the value to. So it's like a sample of the 3E frame formats. And in our testbed, there is an air compressor, which is normally used in the factory. That if you want to increase the pressure, you can use the air to increase the pressure. So we pre-analyze the value, like where it is, like how can we turn it on and turn it off for the convenience of the demo. But in the real case, probably you will not know like which venue, like you can open the something in like some position. So you have to brute force it. But if you try to brute force it, like normally the devices will just dead. So we just try to pre-analyze the package. And here we are trying to mimic the malicious action in Stuxnet, because it tried to causing the centrifuge to tear the machine itself to apart. So we try to push the limitations of that devices to the upper limits and try to manipulate the data in the human interface. So this is how we attack. Like we find devices in the network and then check the version, because we have to make sure that we are going to send the correct instruction to the correct version of the devices, and then read that data and then change. Then send control for DOS. So it's like not so hard. So this is our devices, which is also we borrowed. And it's like super expensive also. And here's the thing is that there will be a human interface like this. And here's pressure is the SV value. So the upper limit of SV value is like a 2.9, something like that. And when the SV value is decreased, the air compressor will open. And for now, the air compressor is off, and it's like showing as yellow. But when it's on, it will become red. So we try to use our tools to start doing the steps we have mentioned, and then we find a target POC, and then we check the POC type if we are going to do some attack, and then read and then send the control instruction to it. And here what we do is first we try to confuse the human beings. Like actually the SV value now is 2.93, but we just send the frame to make the HMI, the human interface, to display as 6.72. So if like operators see the HMI, he may think that there was something like abnormal in my devices. So he might trigger the protective solutions or like mitigations actions, and it will cause problem. And the next one is we have pre-analyzed the value, which position of the value that will trigger the air compressor. So we just keep sending to make it open the air compressor like all the time. So it's like the pressure is like keep increasing, and we are afraid of like tearing these devices apart. So we just stop at the upper limitation. Okay, sorry. Okay, so that is a showcase of our tools. And if you want to use these kind of tools for enterprise, we try a lot of, we bought our own devices and we borrow, and we face a lot of problems and issues. And if you try to do this, and no matter you are using the Caldera OT from MITREs or other payloads, it might damage your devices like physically. So just don't try to do it. And there's a concept of this kind of adversary emulation in the OT system is that digital twins. You try to virtualize your physical environment to like a virtual version, but actually it's super hard because if you try to virtualize devices to something like QEMU, you may face a lot of issue when you do some boot loading. So, and probably it depends some values in the hardware hard-coded value so that you cannot even run it normally. So it's just a concept, but there's no solutions for OT adversary emulation for now. Only the way you can do is you have the money to build a physical like beta environment to do something test like this. So for now, it's like no solution besides you are rich. So this is the takeaway of our session. The first is what is the adversary emulations, and we review the ICS malwares, and we have some like little summaries, and we find some trend, and we use the summary to make tools, and we demoed the two different protocols of attack. So you may find that actually if you want to learn like ICS attack is not so hard because like most of the devices, they have like zero protections for accepting instructions. So the hardest part is you have to get the real devices to attack. And I have to say that a lot of security researchers using emulator to research, but they won't tell you about that. But I recommend you just try it. Try to buy the physical devices because when you send payload, the result will be totally different. And then there's like a concept of solutions in OT adversary emulation is like digital twins, but it may not work. So this is the end of my presentation. Gracias.
Gracias, Vic, y nos reencontramos a las 2 de la tarde con la siguiente charla.